It's a good day to work on the Centurion. Hello and welcome back, and well, we're back out here in the garage today, not just because I don't want to clean the table because it's way too messy and I'm going to deal with that later, but also it's just gorgeous outside. It's below 90 degrees, which is pretty rare for Texas this time of year, and just wanted to be out here in the garage with these big blue computers that I have. And so speaking of the Centurions, there's two things that I want to tackle today. The first is that I want to address the counterfeit system and the previous video, or more specifically, the reaction to the previous video, because there was a lot of opinions about some of the things I said. I think a lot of misunderstanding was coming from the fact that I mentioned I wanted to modify a front panel. And so I want to just clear all of that up right now. I am not going to modify the counterfeit chassis in any way. It will be stored exactly like it is, kept safe and sound, and at any given point in time in the future, if a museum is interested, or if I just want to build up the counterfeit chassis again, we can do it. The chassis is going to be complete. The only thing I'm doing is that I'm pulling the cards out of it and putting them into a different chassis. And the front panel that's going to get modified is the front panel of the different chassis, the spare genuine chassis I have. I'm not messing with that chassis at all. And since the cards are not the original counterfeit cards, they were replacements, and they're all genuine Centurion cards anyways, I'm not really pulling away from the original counterfeitness of this machine. I know that a lot of people probably disagree with everything that I've just said, but the important thing to remember is that it's all 100% reversible. It's kind of like Legos. We can put them together however we want. And if a museum shows interest in the machine, we can build it up to however they want to display it. But until that time, the machines are here in my garage, so I'm going to try and build them up however makes me the happiest. But do remember, it's all completely reversible, and we can do anything we really want with it. All right, so we got that out of the way. The second thing that I want to tackle today is by far the more interesting thing, and that is I want to work on this card and that blue box right there. That's right, today we're going to try and work on the Finch drive because I think it has the best chance for having usable data stored on it, and I'm really hoping we got an operating system hiding out on there. But before we can figure out what's on there, we've got to make sure that the FFC card here is working correctly. So let's put this on the bench. We'll take a look at some of the issues that we have with it, and hopefully we can get it all fixed up. We can plug it into the genuine chassis here, run some tests on it with the diagnostic card, and then we'll try to pull the Finch drive out of its box, and well, we'll just play it by ear from there, because at that point we're getting into unknown territory. I have no idea what's going on inside of that box other than that it looks neat. So let's start with this. We'll put it on the bench and take a look at it. Let's go ahead and get started. All right, here is the FFC board, and I gotta be honest, it's probably my favorite board of all the Centurion boards that I've come across. And that's because it's actually a dual board. There's two boards connected to each other through what they call jacks, but they're actually just IC sockets plugged into each other, and then the whole thing is bolted together with 5 bolts and little studs to screw into. It makes troubleshooting the board so much easier because both boards are just 2-layer boards. If there's a problem somewhere, we can trace it out a lot easier than something like the multi-wire board. And the multi-wire boards are an interesting analog to the FFC board here because they both use the same type of construction. They both have the AM2901 bit slice ALU with a bunch of ROMs that contain microcode, and the FFC, CPU6, and CMD boards show us a kind of cool historical timeline for how Centurion was building their boards. Because when they made the transition to using the AM2901, they started with just dual-sided PCBs connected together with daughter boards. That's how the FFC was built. That's also how the CPU5 was built. However, as they transitioned to more complex designs and needed more density, it made more sense to go to the multi-wire design. And the CPU6 is the first multi-wire design that they built. And then building off of what they learned with the CPU6, the CMD board was the penultimate multi-wire board that they built for this particular backplane. But getting back to the FFC card here, you can see that the stickers on the bottom 3 ROMs here have actually been changed. And that's because before I did absolutely anything else, I wanted to pull the data off of the ROM chips. Because if anything goes wrong on this, everything is replaceable except for the code in those ROMs. And the first 5 ROMs, H1 through H5 here, all pulled off fine. But when I got to H6, I started getting flaky reads, and H7 wouldn't even read at all. And upon closer inspection, these 3 ROM chips, just like the 4116s on the memory board, had suffered some water damage and had some corrosion growing between the pins. So I pulled out my toothbrush along with some very light sandpaper and a lot of deoxit, and I scrubbed like crazy, which unfortunately destroyed the stickers that were on top. But I think I got them clean enough, and I seem to have gotten some pretty consistent reads out of them. And all of the ROMs looked like they were putting out real viable, consistent data, with the exception of one ROM, which was just all zeros except for the last byte, which was 01. But it's an incredibly small ROM, so if push comes to shove, we might be able to reverse engineer the entire board and figure out what that ROM is supposed to be doing. But for the time being, we're just going to assume that it's correct, and we're going to plug this thing into the genuine chassis and see if we can get the diagnostic board running some tests on it. First things first, it's been a while since I've powered the machine up, so let's just make sure that everything is still functioning as it should be before we start changing things by plugging the FFC card in. So I'll go ahead and turn the power on here. And we get a little bit of junk up top, but it looks like it's booted up. I'll push the button on the diag card to boot into TOS, and yeah, there we go. We've got 846F. Now, it's important to note that TOS doesn't actually clear the screen, which is why the junk that we get on boot up is still there. But if I hit Control Local, Control Erase, and then turn off Local, we get a little T/, which means we have our TOS prompt back. If I do M8000, that is the memory address for the ROMs that are on the diag card, so we should be able to see the hex data that's in those. Yeah, 3AB1B80005. So TOS is working totally fine, but we're not going to test the FFC card with TOS. We're going to test it with the auxiliary tests. So I'll change over to test 0D. Yeah, there we go. We've got our auxiliary test menu up. The tests that we're concerned with are going to be 0E, 0F, 10, and 11. These are the Finch tests. And if we just run those now for kind of a before-after comparison here, 0E is trying to do something, and then it says F out never came on. We'll do 0F, see what it does. Again, F out never came on. How about 10? F out never came on. And then finally, 11. It should pass this. Yeah, pass. Press space. Okay, so that's our before state. So let's turn the power off, slot the FFC card in, and give it another try. All right, we've got the bare minimum complement of cards that we need to be doing everything that we're doing. We've got the CPU6 in slot 2. It has to be in that slot. We've got the MUX card in slot 5, the 128K memory card in slot 8, and then finally we've got the diag card all the way over here on the end in slot 16. So we'll go ahead and slot the FFC card into slot 12 right here in the middle. Now in the front of the FFC card here, we've got the really big connector here, which is for the Finch, as well as the smaller connectors here, which are for the Finch and floppy. I'm not really sure I remember which one of these go where, but this 26 pin on this side is a DMA connector that needs to connect up to the CPU 6. So we have a little ribbon cable that's going to have to run right across the front here to connect those two up to each other. There we go. All right, we'll kick the power back on, and hopefully nothing goes up in smoke. Well, that's good news right off the bat. We fell straight back into the auxiliary tests, which means that the FFC didn't crash the whole system. And I don't see any smoke coming out of it, and that's fantastic news because this is probably the first time any power has been put into this card in like 20 years at least. So let's just go ahead and run test 0E here, the Finch aux memory test. Let's see what happens on it. Okay, well, it doesn't look like it's doing anything up here, but oh my gosh, if I look at the front panel, the LEDs are going bananas. It's a wonderful blinking lights show. That's awesome. Now, if I remember, the CPU 6 instruction test essentially just runs in a loop until you hit Control-C, and when you hit Control-C, it exits and tells you whether it passed or failed. So we'll hit Control-C, and it says pass, press space. That is fantastic news. That means that our FFC card is pretty much functioning correctly. Now the next two tests, 0F and 10 for the Finch seek and Finch read tests, should fail because we don't have the Finch hooked up to it, but maybe they'll fail in a different way. So let's give that a test. We'll do 0F, and that says a 41 error, which is totally different than FN failed to come on or whatever it said before. So it definitely failed in a different way, and I don't know if that's expected or unexpected. Let's try the Finch read test. Let's go 1, 0. Oh my gosh. It's going crazy. It's streaming very quickly, and I can very obviously see that it says error, but I'm seeing track in the middle there. Let's hit Control-C, and well, it says fail, but we see here it says track 0200, 0100, 080, 40, 20, 10, 8420. But apparently it's trying to seek to different tracks. Our FFC card is working well enough that we should be able to read the Finch drive. Now we just have to work on getting that Finch drive set up. So let's pull it out, put it on the bench, and start taking it apart. The Finch is no slouch, but it's also no hawk drive either, so I can actually lift it myself. And now that we have it on the bench, it's just 4 bolts on the back plate here to get it off. And once we've got those 4 out, we can pull all the mess of cables out of it. And then everything is mostly bolted in place from the bottom. And the first thing unbolted was the fan, so we've got it out of the way. And then next up was the power supply unit itself. It was just held in with 2 bolts. With those removed, it slides right out the back. And then I set the machine back flat, removed the last 2 bolts, and I was able to slide the Finch drive itself straight out the back of the case. With the drive removed, I could now disconnect the command cable, and then I could finally get a look at the janky power connection that was driving me nuts because it was all taped up with electrical tape. And looking at it closer, the wires are soldered directly to the pins of the connector. So I desoldered the cables to get them loose, but also this gave me a chance to smoke test the power supply unit. So I plugged it in and checked the voltages coming out of it, and well, thankfully no smoke came out. And the voltage values read a little high, but that's actually not unsurprising because there is no load on the power supply. Now, I don't have a plug that fits the power connector directly, so I actually soldered wires to the connector again, but those wires actually go to separate connectors that allow me to actually disconnect the power supply from the drive. All right, we've got our new power connectors plugged in. I've quadruple checked the colors here versus a picture I took beforehand just to make sure that I didn't get anything wrong, and that's all correct. And well, we don't have any of the data cables plugged into it or the control cables plugged into it. And so if we power it up now, what should happen is it should spin up, the head should seek a little bit, and then fall back to a set position at track 0 and just sit there. We're going to give that a shot, and hopefully it all goes well. The first step we got to do is we got to move this little lever from ship to operate. I believe this is what locks the heads in place. Whew, okay, this is a big, big moment. Here goes nothing. It has spun up. Oh, I see the heads moving. It sounds decently quiet. There's no evidence of head crashes. This is amazing news. All right, I'm going to power it down. Oh, I heard a brake kick in. I think that's what it was. It was a weird sound, but it started slowing down much faster than that. So the Finch powered up. The heads seeked correctly. I think we're ready to go for broke and plug the cables into the computer. All right, we are very rapidly approaching the moment of truth, and I'm getting a little nervous. We've got the Finch drive plugged into the FFC card. It did require an additional cable that I wasn't expecting. Because coming out of the Finch drive, this big 50-pin cable has a male connector and the FFC card has male connectors. So it required a little short female-to-female 50-pin cable that's actually used for the disc 1 to disc 2 cards, I believe. I have no idea how it was hooked up in the counterfeit system originally. It was all completely separate when I received it. Now, there is a very specific order that we have to power things up in. The computer needs to be on and stabilized before the Finch drive is on. If the Finch drive is on and spun up when we turn the computer on, there is a chance that while the Finch floppy controller card is initializing, it can send the wrong signals to the Finch drive itself, which might erase some data. So we want the FFC card to initialize first. Now it only takes a couple of milliseconds, so if we powered the power supply off of the switched main power supply down there, then it shouldn't be a problem because this takes a couple of seconds to spin up. And speaking of spinning up, let's go ahead and get this started. I've already got the terminal on because I was too impatient to let the CRT warm up in the middle of all this. So we'll turn the computer itself on. I can see it says auxiliary tests. That's our Finch test that we're going to run there. I will now turn the Finch drive itself on and let it spin up. It is spinning up. It takes it, I don't know, about 30 seconds, I guess, to get up to full speed. I saw the heads in there do their initial seek and then go to a resting zone. So we will do 0F, which is the seek test. This is genuinely the first time I've ever done this. Still got 41 error, huh? All right, let's do a read test instead, see what happens. Error, 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 error. That didn't work. Sometimes that's how it goes. We got some troubleshooting to do. All right, I've been troubleshooting this for a while now, and it's taken no prisoners, that's for sure. I started with the most obvious thing, which was the unit select jumper on the Finch drive itself. It was set to 1. I changed it over to unit 0, thinking that maybe the FFC card was expecting a specific unit. No change, exact same failures. Then I tilted it up on its side and I checked the voltages, and the manual calls for a plus minus 2% variance on the 3 main voltage rails. And the 5 volt rail comes in pretty much bang on. It's at plus 4.95 volts. That's fine. The minus 5.2 volt rail measures at minus 5.08, and the plus 24 volt rail measures at plus 23.4. Both of these are slightly more than 2% off of what they should be, but I'm going to assume that they're close enough to essentially work because The CDC power supply that we have here is totally non-adjustable. I can't tweak any of the voltages in it at all. It puts out whatever it puts out. So for the moment, we're just gonna let it do its thing and hope that that's close enough. The next thing that I checked was I pulled the FFC card out and I popped all of the ROMs out of it because we had those 3 ROMs that had quite a bit of corrosion on them, and so I thought maybe the corrosion had gotten into the sockets. So I sprayed a bunch of deoxit in the sockets and I scrubbed them with a brush. I put it all back in and tried it again, and it's the exact same failure mode. And so I think if we were having weird flaky microcode issues, we would get different failure modes, but it's pretending like the drive doesn't exist at all. I mean, the failures that we're seeing on the terminal are exactly the same whether the drive is plugged in or not. So then I started thinking that maybe the drive is not sending the drive ready signal. So on the 50-pin connector that comes from the Finch to the FFC card here, I've got the pinout for it from the Finch manual, and actually half of the pins are just ground, and of the remaining 25, about 7 or so are either empty or reserved for future use. So there's really not that many pins involved. The drive ready pin, which it says is on pin 22 here, it essentially tells the FFC card that the drive has spun up and is totally ready to go. But that drive ready pin stays at a logic low the entire time. So if the drive ready pin is not making it to the FFC card, then it's never actually going to send any commands to the Finch itself. Now, there could be 2 things causing this pin to stay low. There could be a logic fault on the FFC card itself, pulling that pin down, not letting it go to a logic high, or there could be a problem with the Finch drive itself never actually sending the drive ready signal. That could be due to a logic problem that doesn't let the signal make it, or it could be something a little deeper in that the drive fails a self-check or something and it never actually decides that it's ready. Either way, it's going to require a lot more troubleshooting and digging into these things a lot deeper. And, well, we're going to save that for the next episode because that may end up being a very time-consuming thing. And I'm pretty sure this episode's already running a little long. So I want to thank you guys so much for watching and joining me on this journey that maybe didn't end in as exciting of an end as I was hoping for. But hopefully in the next episode, we can get some genuine stuff out of this. So thank you guys so much for watching, and I hope to see you in the next episode.